Good afternoon, everybody. Welcome to the session on Earth Engine map visualization techniques. My name's Christian Adams.
I'm Justin Braaten.
And we are from the developer relations team. So welcome. I see we have a really big room and not such a big session, so feel free to come on forward if you want to do so. But hopefully you can hear us throughout the hall. So welcome, everyone. The slide deck that has all our slides and links to the demos and the code is at the bit.ly link that is on the first slide there. It's also at the bottom of this slide. So today we are going to talk about styling data for visualization in Earth Engine, raster and vector data. We're going to talk about the difference between the on-the-fly maps in Earth Engine and static maps, some platforms that you might want to bring your data out of Earth Engine into, with a focus on exporting map tiles and bringing those into Google Earth. And we'll talk about some of the details around that, such as cloud storage buckets and cores and things like that, that we will get into. And just as a little preview, we're going to talk about, these are the platforms that we're talking about when we say, bringing data out of Earth Engine into Earth Engine again, like our code editor and apps, you can do that. But more interestingly, into Google Earth, both Pro and the newer versions, as well as Google Maps, APIs, GIS tools, web mapping tools, et cetera.
All right, so regardless of where you view your map data, for instance, in that previous slide, there's this typical workflow that starts in the Earth Engine API. And the first step is that we need some data, an image or vector. Throughout this presentation, we're mostly going to be talking about images. So from here on out, basically what I'm going to talk about is images. And so in this first step, we need to compute or import an image. We need some pixels to paint and visualize. The second step is to apply some styling to the numbers in the pixels so we can make sense of it when we're looking at it. And then we display our styled image. And likely at this point, we're going to iterate between styling and visualizing, displaying on a map until we're satisfied and happy with the result. And that's maybe where you stop. You've gotten all you've wanted out of a visualization in the code editor. But we also have the option to export map tiles for use later, and we'll go into some reasons why you might do that. So starting out, this first step of computing or importing an image, we need to get this image, and there's several ways that you could do that in Earth Engine. The most straightforward is just to load an image that's sitting in the asset store. So in this code example here, I'm calling ee.image. I'm making an image object out of a path. This happens to be the path to a digital elevation model. We could also filter an image collection, so a directory of images. We don't know exactly which one we want, but we know the region that we're interested in, maybe a date range, and some other attributes, and we can filter the collection to these attributes. And in this case, we're calling first. So we have done this filtering, and it's still a collection at the end of your filtering and sorting process. But when we're visualizing, we want to be working with a single image. You can visualize a collection. We can talk about that more later. But for this, it's simple just to think about a single image, so we call first. And then the last option is a computed image. This is an image that does not exist in the asset store yet. You get to make it up as you go. And so in this case, we're calculating the normalized difference vegetation index on our filtered image. So here's just a few ways that you might create an image to visualize. And the next step is styling, but before we get to styling, I think it's important to mention that what we're actually viewing in the code editor and in these other platforms, these web-based map platforms, are generally image tiles. And it's a mosaic at various zoom levels in the Mercator Maps projection. And so if you're in the code editor, and you've probably seen this before as you're zooming in and out, you're seeing individual tiles load at a time. These, we can call them thumbnail images. It's a PNG or JPEG representation of your image data. And So you can actually see this in the code editor, like I mentioned, as you're scrolling in and out. You can see these tiles being loaded. But what's also really cool is that you could open up your developer tools and click on the network tab, and you can actually see these images being downloaded. At the bottom there, I've included a URL to this particular tile, and we can see that it's at zoom level 10, and that it's the 666th column, 446th row. And so this is an important point that we're working with. What you're seeing is these PNG or JPEG images. And so in one way or another, all of the image data that you are working with, when you visualize it, needs to conform to this format. You know, it needs to be 8-bit data. That means we have 256 values to work with, and that's a little bit limiting. And we can visualize it as grayscale, paletted, or RGB, and optionally have an alpha band as well. And the way that we can do this is with ee.image visualize. And so imagine that you had data that went outside the range of the value 255. You need some way to compress it. And we do that through these parameters in visualize. We select a band. We want to visualize this band. And we want to visualize this value, a minimum, to a value maximum. We can optionally apply a palette to this data range, and also an opacity optionally. And so this is an example of a DEM. So this DEM is 16-bit data. This region happens to have elevation that is mostly between 200 and 2,500 meters. And so we need to compress this data range down to 0 and 255. And ee.image.visualize will do that for us. It'll take that data range and compress it down linearly between 0 and 255. So now we have 256 shades of gray or color that we can apply to this image. By default, if you don't specify a palette, you get grayscale. But you could also specify a palette, and I've done that here. I've picked 3 colors that I like. And in the palette parameter, I provide them, and it linearly maps them across these 255 values and stretches it across our data range. And we get this really cool result. This is on the border of Washington and Idaho. What you see there are rivers, the Snake River, the Salmon, the Clearwater. And I think this is really cool. It reminds me a little bit of lightning. And so this is how it looks in code. So that's the elevation model. In that first line, that second chunk of code is the grayscale. And so we've called the visualize function on our elevation model. And we say the band that we want to visualize is elevation. The minimum and the maximum are 200 and 2,500. And then in the third one, we have the paletted. And the only difference there is that we've added the palette argument to those 3 colors we just saw previously. And so this is discrete, or excuse me, previously that was continuous data. This is categorical data that we can do this to as well. And if you're going to be doing this with categorical data, it's important that the classes be sequential. So this is land cover that we have here. It has 9 classes. It happens to be the dynamic world data set, which is pretty cool. And conveniently, it goes from 0 to 8. If you had data that was spread apart, you would want to do some reclassification to get it into a sequence. And then all that we do is provide the min and the max for the range of their classification values, and then make sure that you have as many colors as there are classes. So here we have 9 classes, and we provided 9 colors. So up to this point, we've talked about single band display, but we can also display 3 bands as RGB, or red, green, blue. And in this, we're relying on color mixing of these 3 colors, red, green, and blue. And what we have here is a Sentinel-2 image with 3 bands, the green band, red band, and near-infrared band. And we've applied red to near-infrared, green to the red wavelengths and blue to green wavelengths. So this is a false color composite. And I guess one interesting thing that we can talk about here is color mixing, how this works a little bit. So in the composite image, we can see a lot of red. It looks to me to be a forest region. Are you able to use the mouse to scroll it?
Yeah. In here?
Yeah.
That's a park.
It's a park, and it looks so it's trees. And if you look over in the color components, you'll see that that region is really bright in the red component, but dark in green and blue. And so when you blend all those together, the dominant color there is red. So that's why you see it as red in the composite.
I think that's Boston Common, right?
Could be.
In Boston? Probably.
I've never been there. And so this is how we're visualizing RGB in code. Looks very similar to visualizing a single band, except that now for the band arguments, we're providing 3 bands instead of 1. And I also want to note that to this point, the min and the max value has been a constant, but you could also specify a min and the max value per band, and that's what I've shown on the right-hand side for the false color. And we also have the option to add transparency to our imagery using an alpha channel, and then it would be a PNG image that you're viewing as map tiles. And transparency is controlled by image band masks and the opacity parameter. Band mask values between 0 and 1 correspond to opacity, 0 being transparent and 1 being opaque. And you could have any decimal value in between. That would be some gradient of transparency. And band mask values override the opacity parameter. So if you are using the opacity parameter and you're like, this isn't working, it's probably because you have some opacity in your masks. And each band can have a different mask value per band, and it's just also important to note here that if there's confusion, that the minimum mask value is applied in visualization. And so now we're at this step. We have got an image, we have styled it, and now we are needed to display it and kind of iterate on styling. And there's sort of 2 environments that you might be doing this in commonly, and that would be maybe Python or the code editor. So I've shown here on the left an example of the Colab notebook. And in the Colab notebook, we don't have a map visualization tool sort of natively. And so what we're doing here is we're using IPython display to show a thumbnail image. And then on the right, we have a little screenshot of the code editor. And as you're styling and iterating on this, you're maybe changing the min and the max values and changing your palette. Sometimes it can be difficult to determine what your min and your max should be. In the code editor, we have a tool that can help you determine what those should be. If you load up the raw data unvisualized into the map with map.add_layer, you can click on the layer in the layers component and get onto the visualization GUI. And there's a drop-down selector that will stretch the data between different different parts of the histogram. And it's getting the statistics from only the pixels that are in the viewport and only the pixels at the zoom level that you're at. So 98% is a pretty nice one generally. You could also do this programmatically by reducing the pixels in a region by standard deviation, or in here we are looking at percentile. The 2 and the 98th percentile would be our min max that we would be trying out. And so at this point, we're on to step 4, perhaps, where you might decide that you want to export your visualization as map tiles or not. And the decision might come down to whether you want to have the power to compute or you want static tiles. So when you're in the code editor, the tiles are computed. Every time you make a request, new data has to be generated, new map tiles need to be generated. And so it's a little bit slower, and there's computation involved. But you could also have them static. You could export these map tiles and then you take out this computation step, and your data are coming directly from the server when you request them, so it's much faster. And computed tiles you might think of in the code editor as functions like map.addLayer, or if you are displaying map tiles in Python, it might be ee.image get map ID. And like I said, all those are computed on the fly, and it's great for fast, like rapid interaction, exploring and prototyping. You can be changing things and then seeing what it looks like pretty quickly. But it is relatively slow to static tiles, so it's a slow display speed and it's high compute. So if you were developing an app, it might not be a great user experience for your users, and you could be using a lot more compute than you actually need. So static tiles is an option where you export the visualization to cloud storage. You could also sort of do this by exporting to asset, but it's not the actual map tiles. So again, there's compute involved. And so these are computed, you export it, and it's stored on disk. And so when they make a request, it's very fast to load, so it's great user experience, and it's low compute. But it is read-only, so you can't modify that data. So if you want your users to be able to just make their own kind of display, this might not be the right option for you. And there are also other ways that you could visualize the data. You could export it as GeoTIFF or COGS, thumbnails, and view them in a whole variety of other platforms. And so up to this point, we've been talking about image data, and that's what we'll focus on. But just to say that you can also visualize vector data. And an important point to make is that when you visualize vector data, it's actually painting shapes onto an image, and then you're styling that image, essentially. And so they're not vector tiles, and you cannot style them and, for instance, export your styling as a KML. It's actually an image is what you're going to be looking at. Another really great option and a new feature for us in about the last 6 months to a year is feature view. And so this is for vector data, and it's really fast. It is pre-computed tiles. It's only available in the code editor and Earth Engine apps, but if you're making an Earth Engine app, definitely look at this. You can see the comparison here in load time between the feature collection on the left and feature view on the right. And it also has really great styling capabilities. So with that, let's try to export some data and work with it.
Thank you, Justin. Yeah, so you've done your analysis, you have your data set, and you want to share it out maybe through Google Earth or some other platform. So let's talk about how you can get your data out and where you might want to use it. So same list as we saw earlier. You can bring things back into Earth Engine, but more interestingly into Google Earth or Maps, GIS platforms, web mapping platforms, et cetera. So let's step through each of these really quick just to talk about which formats work with the different platforms. And for each of these, we have our raster data and our vector data. So you can export stuff out of Earth Engine and bring it right back in. For example, into the code editor if you need a static layer, or into your EE app if you want a highly performant static tile layer for serving there. You can do that. And you can do that through a GeoTIFF or through map tiles. Of course, can bring both of those back into Earth Engine. And for vector data, Earth Engine can ingest shapefiles and CSVs and create a table asset, as we call it in Earth Engine. Moving on to Google Earth, let's start with Earth Pro, the desktop client. This can import a number of formats that Earth Engine can create. So if you have a GeoTIFF that you've exported, your image with the geographic coordinates embedded in it, Earth Pro can actually import that. And if it's a small enough image, it will just lay it on the map on Earth where it belongs as part of that import process. If it's a larger image, it'll give you the option to either scale the image or crop it, or to create a tiled version. In Earth Pro, it uses something called a KML super overlay, and it chops it up into tiles and little KML files, a tree of them that make that work in Earth Pro. So that's how you can bring GeoTIFFs into EarthPro. Another thing you can export from Earth Engine is the simple image thumbnails, and those, of course, can be used in things like your balloons or other stuff like that. On the vector data side, you can export KML, and of course, EarthPro can bring in KML. That's its native language, what it speaks. So KMLs or KMZs. EarthPro can also ingest shapefiles. You can import those, and you get some options for styling them when you bring them in. And that's a nice option if you want to be able to actually deal with some of the attributes in your tabular or vector data. And of course, EarthPro can also import CSV and GeoJSON. Moving on to what we call New Earth, or the newer version. It's not so new anymore. It's been 5 years, so I should stop saying new. But the web and mobile clients, there we have the ability to bring in map tiles. So when we talk about exporting map tiles from Earth Engine, we can bring those into New Earth. And we'll dive into examples of that and demos of that in depth in a few minutes. You can also use the image thumbnails in similar ways in your balloons. And for vector data, of course, support for KML and KMZ. If anybody is a journalist or other Earth Studio user, that also supports map tiles. You need to know how to construct the KML for those. Let me know if you want more details on that. Yeah, you can bring in map tiles into our studio for an overlay, or of course KML and KMZ into our studio as well. Though a little caveat there is that it only supports one folder level in the list view. If you're using My Maps, not much raster data support there, but you can use image thumbnails again in your balloons, et cetera. But you can, on the vector side, bring in KML, import that as a layer into your My Map, or CSV. Patrick talked this morning about some of the new capabilities with Google Sheets and sort of dynamic uploading or dynamic syncing of data with the Google Sheets in My Maps. So exciting progress there. If you are building your own website with a fancy map on it and using the Maps APIs, or a mobile app, or whatever you're doing with the Maps API, you can use some of these things as well. So map tiles, the Google map tile format, came from the Maps APIs as the way to overlay raster data on the map. And so that, of course, works in Google Maps platform, as well as the ability to bring in KML layers as a single layer. If you have CSV or JSON, you can also use those, but you'll need to parse it out with your JavaScript code in the API and then add it to the map piecemeal. If you're a GIS user, using ArcGIS, QGIS, any of the other JS packages or online services, most of them support all of these standard formats, from GeoTIFFs to shapefiles, KMLs, et cetera. So have at it there. And then the web mapping tools, that's a bit more varied. Depends on which tool you're using. So many of the standard formats are supported there as well, and you'll have to look at the documentation for the service you're using. All right, so let's get into into the nitty-gritty here. We want to export some map tiles and bring them into Earth to create a beautiful visualization and maybe tell a story around it, something like that. So let's figure out how to do that. Here is a chunk of code from our demo that is the tile export part. And you'll see a few important things. First, you define the image that you want to export. And importantly, this needs to be an image, not an image collection. I know I still make that mistake sometimes. Like, why doesn't it work? Oh, it's an image collection. No, I need to get it down to one image, or filter my image collection, right? So your image to export, you give it a description that gets used for the task name and the output path if you don't provide something more specific. You need to tell it which Google Cloud Storage bucket or GCS bucket, and we'll get into the details of that in a moment. You need to tell it what file format. Most of the time, just use auto. You can also specify PNG format, which allows for transparency, or JPEG format, which is more efficient. You'll get smaller files, but it doesn't support transparency. Auto will automatically pick if that tile has any transparency in it, it'll use PNG. If not, it'll use JPEG for the efficiency. You can define a path if you want for where in your cloud storage bucket your tiles are going to go, some zoom level stuff, a region, that is what area you want to export. You'll need a geometry, whether it's just a simple box or something more complex that you want to export. And it's a good idea to clip your image to your region before you export for a variety of reasons that I can tell you more about another time. And then there's some permissions things. So when you dump all these tiles out into your bucket, you need to tell it, for most use cases, you're going to want your tiles to be publicly accessible so that Earth can fetch them and maps can fetch them, et cetera. So most of the time we do write public tiles as true. And then we'll talk a bit about something called CORS, cross-origin requests. When you go and get a file on the web, as the user, you're clicking on it and downloading it. The only thing that matters is if it's publicly accessible or not. But when you have something like Google Earth or the Maps API going and fetching tiles via its internal JavaScript, some websites will block that. And so you need to make sure that the server where you're serving your tiles has the right CORS headers set that say allow either all websites or Google Earth or Earth Engine or specific or my Maps API site, my domain, to fetch these tiles. And so in this case, we have the bucket CORS URIs set to allow code.earthengine, which is the code editor, earthengine.app, which is any Earth Engine app, and earth.google.com, which is the Google Earth web app, to fetch these tiles. All right, so that's the basics of exporting tiles. Justin's going to go into a bit of a demo, and then we'll talk about some of the details in a little more depth.
Thanks, Christian. Yeah, so we had this idea that we wanted to explore wildfires in California a little bit. And one way that we can do this is just with Landsat imagery, just a basic visualization. And it happens that if you include SWIR, shortwave infrared, and near infrared in your visualization, you can kind of make fire scars pop. And if I had a superpower, it might be to see the world in this way, shortwave infrared, near infrared, and green as red, green, and blue. And so I've made this little demo that creates a visualization of California from Landsat data, Landsat 9, the summer of 2022. And so what I've done here at the top, I've defined a region of interest that I'm going to clip my visualization to. This is the state of California. In this next chunk of code here, I am creating a function that will scale and mask the Landsat data. So there may be clouds in the imagery, so I'm going to take as many images as I can in this summer season, make a composite. Each image will be masked so that if there are clouds, underlying pixels will show through if they are clear. And then in this chunk of code here, take my image collection, filter to the bounds of the state and the region, the season that I would like, and I map my mask and scale function over the collection, and then I call median on it to create a median composite of the intersecting pixels. And then I know this by heart. This is my favorite representation of Landsat data, so there was no iteration on styling needed here. And then in this line, I call visualize, like we were talking about earlier, with these style parameters. And then I clip the image composite to the state of California, and then add it to the map. And that's what we're seeing here. And these are all a bunch of small map tiles at this given scale, or zoom level. And it's sort of an enhanced true color. So greens are still vegetation. They're just a little bit brighter. Browns and tans are unvegetated or lightly vegetated. And so what we can see here, this is the Sierra Nevadas. And we've got forest here. And it's interspersed with this brown, kind of reddish area. And these are wildfires California in the last few years has had a lot of fires in this area. If we zoom in, we can see that now we are fetching tiles on the fly, like we were talking about earlier. And so what we're going to do is export these map tiles and explore these areas a little bit better in the digital twin of Earth, where we can see topography better. We can overlay it over the topography and zoom in and out of valleys. And so the last step is the export, and Christiaan just talked about this. So when you run the script, you'll get a task. You would click Run on this task. An interface comes up, and you are basically, it's the same parameters that you have just provided arguments to in the code. So you can either provide them in the code or here in this GUI. I prefer the code. It's a better record and more reproducible. But anyway, you would run this. I think this export took about 40 minutes. We already have the tiles loaded, so we don't have to wait for it. And then Christiaan will show us what we can do with these tiles.
All right. Get back to our demo here. There we go. So we keep talking about Google Cloud Storage buckets to put tiles in. But first, why cloud storage? Why can't I just put them on Google Drive? Well, Google Drive isn't great for hosting things that you want directly accessible on the web. Even if you share it publicly, when somebody clicks on your Google Drive link, you still get a Google Drive web page that has the document or PDF or file or whatever in it. And it's not a direct download link. Direct download links in Drive are hard. So, and it's not really made for hosting stuff on the public web, right? So we use Google Cloud Storage buckets. They are made for this. They are made for hosting stuff. So that's why we use them. And that's why the map tile export function in Earth Engine defaults or only gives you the option of exporting to a cloud storage bucket. So how do we set up a cloud storage bucket? You start at the Google Cloud Console. And there's the link there. I can open it up here. Whoops. Logging me into my account. Sorry. Should have done that earlier. And we get this, and I can go into my list here and go to storage, cloud storage, buckets. And I get to see some buckets. You know, I'm going to skip back here and just talk you through this, because you can explore that. There's a Create Bucket button, and you press that. It'll create a new bucket. Some of the things you'll want are a name for it, the location. I'll show you here in these screenshots how you set it up. Sorry, it's a little small, but again, you need a name for your bucket. This name is universally unique. So if anybody's created a Google Cloud Storage bucket with your name before, sorry, you're going to have to pick another name. You want to choose where it gets stored. This is basically which Google data centers. And by default, it usually does multi-region. So it'll, like, say, you know, if I choose North America, it'll choose a couple data centers in North America for me. I can also get very specific and choose a single region as the bottom option there and choose exactly which data center I want it hosted in. You need to choose a storage class. For tiles, we almost always, I think always want standard storage class. Access control. So almost all use cases for your tiles, unless you're doing something very specific behind a firewall with Maps API, in almost all other use cases, you're going to want your tiles to be public. And so we allow them to be public. And we want fine-grained control over the access so that Earth Engine can specify each tile is a public asset. And then the last option is about how to protect your object data in cloud storage. This is about backups and versioning and things like that, which for tiles we don't really need to worry about most of the time unless you're doing something very specific. I left where's my mouse? There it is. This one checked here, and that will bring up this thing that this extra little window that says, hey, are you sure you want to block public access? Oops, no, I don't. I want my tiles to be public. So I'm going to uncheck that box and move on to create my bucket. So that's some of the concepts for creating a cloud storage bucket. So Justin did the demo, and he started the tile export. Once that's done, depending on how many zoom levels and the resolution of your data, it could take anywhere from a minute or two to tens of minutes or hours, right, to do an export. Many hours if you're doing like a high-resolution global export. But at the end of all that, what you get is a task success here, hopefully. And in this case, it says it took 6 minutes, and it has produced a bunch of things for me. We'll take a look in more depth in a moment. But one thing that a map tile export will give you is these output URLs. So note those two. There's a Google Earth Tiles URL and a Google Maps Tiles URL. And the sort of zoom and X and Y parameters on the end of each one are a little different for those two platforms. And we'll use those in a few minutes. But right now, let's go take a look at a cloud storage bucket. Click into this one. And here is that bucket where Justin's demo exported tiles. And you see all these numbered folders, 0 through 12 in this case. Remember, his maximum zoom level was 12. So we have a set of tiles at 0, which is the global view. And there's only one X folder and one Y file. If we open up that one, see if that's even possible. Oops. There we go. So there's California, that tiny little blip in the middle of that tile, that entire world tile. Let me go back here. If I go to a more interesting zoom level, let's go to level 10. And here I see a lot of X folders. I'll pick one somewhere in the middle. And a lot of Y files. Pick one of those. Let's see what that looks like. Nice. There we go. That's an actual 256 by 256 pixel tile. All right? So you can see how you have this pyramid from zoom level 0 out to whatever your maximum zoom is of all your tiles. All right. You'll notice at the bottom of that export list, if I go back here, there is also an earth.html file and an index.html file, and we'll come to those in just a moment. So a few things to note. I talked about the tile folder structure. The first level of folders is the Z or the zoom or level, as we call it in Earth. The next is the X folders, and then the Y number is in the file name. In the tiles I showed you, there was no extension, like no .jpg or no .png, because I did auto, and it just doesn't add an extension to the files. But anything that's going to use the tiles knows what to do with the files anyway. I think if you specify JPEG or PNG, it'll actually put the extensions, but don't worry about that. I mentioned the index and earth files. We'll get to those. We'll talk about Maps API keys and permissions. If I go back to, well, every tile in there, you might have noticed, had said it was public. And so that's what setting your tiles to public did. And then the JavaScript access, also known as cores, has been set on this bucket. And note that cores are set at the bucket level. So if you have multiple tile sets that you export to the same bucket, they're all going to have the same core settings. So you can check the core settings in your bucket using the gsutil, or you can set those core settings using that as well, and there's lots of documentation. There's also, you can delete an entire tile set either using that cloud user interface or using the gsutil utility. So let's take a look at these tiles on a map. So this is that index.html file. Now, because I didn't provide it with a Maps API key, it's like, hey, you don't have actual proper stuff, and this is for development only. That's why I'm getting these sort of grayed out tiles in that error message. But don't worry about that. If I provide it with the Maps API key, then that will all be cleaned up. But here, we can zoom in on these tiles, and you see how quickly they load, and we can zoom right in on some of these places and look at, we get those zoom levels up to level 12, and can see all that data beautifully, and it loads quick, and a great user experience there. So that's the kind of thing why we want to use these static tiles so that you can get that good experience. We are right about there. Cool. So let's take a look at these in Earth. The index.html file is the maps preview. The earth.html is an Earth preview. This, for a bunch of reasons, goes through a proxy server, but it opens up in Earth Web and gives you this view. And so here, again, we have those tiles. They load nice and quick. We can go zoom in and check out places like this, right? And can see that the tiles on our 3D imagery, which is pretty awesome. And check out some of these burn scars and see how they went up the hillsides and through the valleys, things like that. Some recent ones up here. Right, so that starts to tell us more about our data when we can view it in this context. And it's just really cool for sharing, too.
It looks great.
Awesome. So those are the preview files that you get when you do an export. Get those automatically. And that's nice and easy. I could save that in Google Earth and share that if I wanted to. But what if you have a Google Earth project and you have a bunch of stuff in there already and you want to add a tile layer? Well, I can go back to my output URLs and whoops. I can grab this URL here. I'm going to copy that URL, and I can go into Earth and create a new project. Not that one. Back out of there and create a new project. So here's my brand new project. I can spell. And I can create a tile overlay feature in Earth. And my tiles, give it a name, and it asks for an overlay URL. I put that URL in here, and you can see that it's in storage. It's my EE demos bucket. It's in a G4G folder, and this is the name of my tile set, the CA false color. And then it has these 3 variables. In Earth, we say the $ square brackets with level, X, and Y. And that tells Earth where to find all of these tiles. And so if I go over here to California, there are my tiles. And now I've added that as a feature in my Earth project that I can integrate with other stuff and share as I see fit. One other thing to note in here, when you create a tile layer, it assumes that it's a global overlay. So you can see it's gone from the 85 north to 85 south, which is not 90 to 90. It's the Mercator limits on the Maps Mercator projection, as well as negative 180 to positive 180, so wrapping all the way around the world. If I really wanted to do this right and avoid Earth requesting lots of tiles that don't actually exist in this tile set, then I would go back and get my bounding box for this export and put in the north, south, and east and west bounds for that. But for this demo, I'm not going to take the time to do that. So that's creating a tile layer in Earth and bringing that into your Earth project for sharing or storytelling or whatever you want to do. You can do similar things with the Maps API again. This is a code sample. Actually, I just pulled this out of the index.html file, the sample script provided in the export. So you can go and find that yourself and download that HTML file, and you'll see the JavaScript in there that sort of constructs the image overlay and constructs the URL for each tile in the JavaScript to make the proper requests. So that's how you could bring it into your own mapping web page through the Maps APIs. So Lots of cool stuff overlaying tiles, overlaying raster data. Let's talk for a minute about KML and vector data. Almost done here. We'll get to Q&A shortly. Justin created this awesome visualization where you can see some of the fire scars. So we went into Earth Engine and found the historical fire data boundary data set, and figured we'd try to export that as a KML file to bring into Earth as well. And the first time we did it, just to show you a bit how the sausage is made here. The first time I selected California and I said, OK, export all of those fires to KML, and it made an 85 megabyte KML file, which is a little big, a little hard to work with, and Earth is going to not do very well. So OK, let's do all of them since 2020, and let's limit the attributes to just a few of the attributes in the attribute table. So that came out as a 35 megabyte KML file. Better, but still a little heavy. And then Justin worked some of his magic and added a simplification function to the vector data and simplified the polygons a bit, and that got it down to 2 megabytes. So much better. So we now have a KML file. What happened to my slide? That is not loading, so I am going to show you this in Earth because I think I can find it where I did it the other day. So here is our tiles that we loaded earlier. And in this case, I'm going to turn that one off. Here, as you can see, 2 days ago, I loaded the KML when we were finalizing this presentation. So I'm glad I have it here. Let me turn that one on. Oops. Nope. Nope. Come on. I think I lost network access. What is going on here? Nothing is working. OK. Well, you can all imagine let me go back here. See all those red lines? Those were exported as a KML file and overlaid on top of our tiles. And you can see a fire boundary here. But yeah, the tiles aren't loading. I think I lost network access. So that KML outlined all of those fire scars very nicely. And you could tell a really great story with that. I'm sorry, I can't show you right now. You can also export shapefiles. I'm not going to go into the details here, but there is a sample script there for exporting a shapefile of this fire data. That's interesting because you can bring it into Earth Pro, and when you bring it into Earth Pro, it lets you select which field to use as the name, and so you can do some coloring and other stuff like that if you want to get fancy with the KML. So that's interesting stuff to play with. And luckily, we're almost at the end here. So we talked about image styling, all sorts of cool techniques and details about how to style your raster data as well as your vector data. We talked about exporting map tiles and exporting other kinds of data. Talked about all the different platforms you might want to bring them into. And we talked about bringing map tiles into Google Earth and creating a tile layer. And Justin also mentioned feature view for if you want to do sort of similar things with exporting and displaying large vector data sets. That's a whole other talk on its own, but you can look into that more because all of these links in the slides are to the documentation about all of these things. So go and look those up, find out more information. And again, the link to the slide deck, if you need it, is at that short link at the bottom of the slide there. So with that, and with no network access, we will take some questions. Any questions from the crowd? There are a couple mics here. Come on up. If there's a Googler who wants to run a mic around to anybody, that might be cool too. And we'll need somebody to break the ice.
Here we go.
Awesome.
Hi.
Hi.
Thanks for the presentation. Really
Sure.
interesting. So I'm Sander. I'm working for Just Dig It, doing analysis in Earth Engine, and then like to analyze my results in Google Earth Pro. What is the best way to do it? Since I typically use Google Earth Pro and on the web version, since the web version still has some limitations for me. Currently, I export a GeoTIFF and then use other software to convert it into a KML file. But then I'm always having these issues that the quality reduces. So I have to greatly boost the number of pixels or the resolution in order to get some, since often it's classified data, so sharp boundaries between the colors. What would you recommend as the best workflow to do that?
A couple things there. So you said you're exporting GeoTIFFs. About how big are they usually?
Yeah, it's around 200 megabytes, something like that.
Okay, so pretty big, but not crazy. I think you should be able to bring something up to around that size into Earth Pro. Have you tried importing it directly into Earth Pro?
Just playing around with it.
Yeah, okay.
Hearing
So,
that it has been improved.
yeah, again, if you bring in a large GeoTIFF, it'll ask you if you want to scale it, crop it, or tile it. And in that case, it's creating, again, what's called a KML super overlay. It's a slightly different tile format with a whole set of KMLs in that pyramid to manage those tiles in a way that Earth Pro understands. What we showed in Earth Web is a little simpler because it's just the tiles and it knows how to handle them natively. But in Earth Pro, it will create that KML super overlay in a folder on your hard drive for you. So that should retain the full resolution of your GeoTIFF. Now, I also hear what you're saying about classified data. For imagery, when you zoom in to sort of the full resolution of a raster overlay in Earth, you'll notice that the center of each pixel is the color you expect, and then it interpolates in between, which is great for imagery. It looks beautiful for imagery data. But when you have classified data where you actually expect square pixels of distinct colors, then that interpolation is no fun. And so there's sort of a hacky workaround to that I've used in the past where I export my raster data at 2x or 4x the resolution and then bring it in, and it'll look better in Earth Pro. But unfortunately, that's a limitation of Earth Pro with the discrete classified data that it doesn't do a great job when you zoom all the way in.
No, thanks.
Does that help?
Yeah,
Great.
Definitely. I think the improved GeoTIFF capacity already helps a lot.
Yeah.
Thanks.
Great. Other questions? Over here.
Once we get a lot of colors on a map, we're often asked to then be able to click on them and say what's there. And I'm just curious if with some combination of the raster tiles and maybe Earth Engine endpoints, you can do that without creating crazy KMLs.
Yeah, with your map tiles, it's not clickable, right? It's just an image overlaid on the map. And I think what you're asking is, is there a way to make it clickable, especially if it's like classified data? Click on it and say, this is forest land type, and this is desert or ice or whatever, right? We've simulated that. You may notice in some of the Voyager layers in Earth with a vector overlay that's sort of transparent but clickable, but that's not an easy thing to create, unfortunately. Do you know if feature views retain clickability of individual areas?
Nick, you want to take it?
Do you have an answer?
Yeah, I can answer that. Feature views, you can use the inspector tool with feature views. If that's what you're asking about. So the features are clickable, yeah.
Okay, so if you're using feature views within the code editor, they retain clickability. In EE apps as well?
Yep,
Okay.
in Earth Engine apps as well.
Great. So for viewing in the code editor or in an Earth Engine app, you can export your vector data to a feature view and get that scalability for very large vector data sets and retain the clickability. Right now, there's not an easy way to bring that into Earth, unfortunately. Did you have online questions for us?
I had a virtual Q&A question.
Wonderful.
This one user is asking, they would like to export directly to a PDF format with grid compatible with Avenza maps. Is there some way to get this done without going through any desk GIS?
Want to export something out of Earth Engine to a GeoPDF for use in Avenza. Avenza I used a long time ago, and it's, I think, an app that lets you bring geocoded PDFs into your phone so that, at least I used it to take them offline and go hiking and things like that. I don't believe Earth Engine has any PDF export capability. So I think the answer to that is no. Right now, I can't think of any shortcut to going through some other software. But you can certainly export your image and put it into QGIS or whatever package you have that can take geospatial data and PDF it. Other questions? We've got a couple minutes left. Or do any of these discussion topics bring up any ideas or thoughts for people that you want to share? What kinds of things do you want to visualize? How do you want to do it? What kind of platforms do you want to bring it into?
Hey.
Hey. I had one quick question about bringing data into Earth, I guess, online. Is there the possibility, or, I mean, I'm going to miss this because I walked in late, but is there the possibility to add the height to a feature based on a property?
So have a vector feature that's raised up above the ground?
Yeah, or I mean, if it was a building, or I'm thinking of trees, for example, but if we had the height of a tree, could you somehow stylize that as a cylinder or some sort of shape with the height?
Most of what we've talked about here is raster data, so imagery or classified data that gets draped on the terrain. And there you could certainly have a color that represents height or something like that, but that's not quite what you're asking. To actually represent 3D height in Google Earth, you're going to need vector data, so some shape that you can then make into 3 dimensions. And that's certainly possible with KML. There are limited tools to create those things. If you're creating KML programmatically or by hand, you can do that and create your shapes at whatever height you want. Actually, I think if you export a shapefile where one of the attributes is height, there is an option in the shapefile import in Earth Pro that will let you choose which field to use for height. I forget exactly what that does, but it may get close to what you want. So check that out and come find me later. We can explore it.
Thanks. I'll give that a try.
Sure. One more question.
Hi, Tim Wallace. Thank you for the presentation. Thank you for all your work over the years. I have too many questions. I'll try to do just the one.
Sure.
The ability to do any kind of visualization manipulation in the GUI hasn't changed at all over the years. You just have this one little thingy you click around on, right? But I think probably a lot of people in this room have work where they need to quickly iterate to get something kind of just good enough to send out the door. So I want to know what you in-house, you must, because you work with this all the time too, do you have any hacks at trying to quickly iterate on visualization, whether it's a min-max thing or getting the right colors or what?
Yeah, you could build an Earth Engine app with sliders or drop-downs. I haven't done that personally, but I've seen apps where people do that. So it would select the min and the max via slider, or you would select the bands for RGB. And yeah, you'd have to, sort of tailor it to the data type. It would be a Landsat visualizer or Sentinel-2 visualizer or something, where you'd have another drop-down to select the data, and then it would have to look up different band names and such. Do you have any ideas?
I mean, there's a lot of inspiration you can draw from desktop GIS and also Adobe products and open source visualization products.
Yeah.
But even different histogram stretching, and it seems like it could be possible to add just a couple of
totally
manual buttons and knobs.
Yeah. We'll have to.
Maybe we need to make a code lab that has some examples of how you can sort of build histogram stretchers in the code and
Yeah.
have an app that you could sort of copy and put your own data into to do that easily.
It's
a good idea.
I would use something like that, yeah.
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 Awesome.
That's good to hear, yeah.
All right,
Wanted to
thanks so
talk to
much.
them. Thanks, Tim.
All right. Well, thank you everybody for your attention and your questions, and yeah, for all the great work you do. Thank you. And if you have any other questions, come find us over the next 2 days. Thanks.